Dear children, today we'll discuss about laws of vector addition. So you remember, two vectors cannot be added algebraically. So here I can give one example. Suppose it is a surface. If you place a body on it, if you apply your 5 Newton force and another 3 Newton force simultaneously, then what will be the resultant force? Resultant will be 8 Newton towards right along the direction of the given forces. Here you can say it is 5 plus 3, that is 8 Newton. If the two forces acting simultaneously opposite to each other, then what will be the resultant force? Here 2 Newton towards right, that is 5 minus 3, that is 2 Newton. Here the resultant is 5 plus 3, here it is 5 minus 3. Though the two forces remain same in magnitude. And why the resultant differs? Because of their directions. Here they are in the same direction, the angle is 0 degree. Here these two forces are in opposite direction, means angle is 180 degree. If you apply the two forces at any other angle, then what will be the resultant? Here you cannot get the resultant force unless you know the laws of vector addition. So what is your conclusion? The conclusion is that to get the resultant vector, both magnitude as well as direction, we have to apply laws of vector addition. So in vector addition, which has the important role in the vector addition. So here angle between the two vectors is 0 degree. Here the angle between the two vectors is 180 degree. Here any other angle. When the angle between the two vectors changes, then the resultant vector changes. So let us know what is vector addition. What are the laws of vector addition? So there are 3 laws of vector addition. One is your triangle law, then parallelogram law, then polygon law. So whenever you have two vectors, to get the resultant vector, we will apply either triangular vector addition or parallelogram law of vector addition. But to get the resultant of a number of vectors, if more than 2 vectors are given, to get the resultant vector, we have to apply polygon law of vector addition. So now let us start one by one. So first we start triangle law of vector addition. So what is the law? If two vectors simultaneously acting upon a body and are represented by two sides of a triangle, that representation both in magnitude as well as direction. If two vectors are represented both in magnitude and direction by the two sides of a triangle taken in same order, then the resultant vector is represented by third side of the triangle taken in opposite order. So you see, you have two vectors, A vector and B vector, simultaneously acting upon a body. Here I represent A vector by OP. To represent magnitude, I have to draw a line of same length and its direction is towards right. Here I also put arrow towards right. Means I have represented A vector by the side OP. Similarly, B vector by the side PQ. So now you see the length of B vector means to represent magnitude I have drawn the line of same length, and to represent direction I have drawn this line parallel to this B vector, and I have put arrow towards the Q. So now you see A vector and B vector are in same order. Order means not direction, either anti-clockwise or clockwise. You see A vector and B vector are in anti-clockwise order. You see, it is the triangle OPQ. Then OQ is the third side. Third side will represent resultant vector. And another condition is that the direction taken in opposite order. Here you see the order of this resultant is clockwise. So here question arises, can I represent B vector by this side? You can represent, but if you represent B vector by this, then you see A vector and B vector are not in the same order. If A vector is in anti-clockwise order, then B vector is in clockwise order. Then you cannot apply triangle law. So here, to apply triangle law, the two vectors are represented in a triangle such that the two vectors take in same order. So what is magnitude and what is direction of the resultant vector? So OQ represents resultant vector means OQ length gives you the magnitude, and from this angle I can get the direction of the resultant vector. So first we find magnitude of resultant vector. Magnitude of R vector. To get the magnitude, you draw a perpendicular on OP produced. Let it be QN. So here you remember the angle between two vectors means that is between their directions. Suppose it is A vector, it is B vector, the angle between two vectors A and B is suppose theta, that means if you write it is theta, no, that is not between their directions. A vector direction is towards this and B vector is towards this, so it is not the angle theta, the angle will be this. So you remember the angle between two vectors means that is between their directions. Here you take the angle between A vector and B vector is theta, means it is not theta. A vector direction is towards ON and B vector direction is towards PQ, so this angle will be theta. So now you take triangle OQN, you see OQN is a right angled triangle. So I can write OQ square is equal to ON square plus NQ square. Here ON you can write OP plus PN. OP plus PN whole square plus NQ square. You can write OP square plus PN square plus 2 into OP into PN plus NQ square. Or you can write OP square plus PN square plus NQ square 2 into OP into PN. So what is PN square plus NQ square? You see, in this triangle, this square plus this square is PQ square because PNQ is another right angle triangle. So I can write OP square plus PQ square 2 into OP into PN, equation number 1. So you see in this triangle from the figure, I can write what gives the length OQ, that is resultant vector magnitude. What gives you the length OP? A vector magnitude. PQ, that is B vector magnitude. So now you take this triangle PQN. Triangle PQN. You see PQN is a right angle triangle. If you apply cos theta, that is PN by PQ, that equal to PN by B, or PN B cos theta. You write it as equation number 2. Similarly, in this triangle, sin theta is equal to P by H, Qn by PQ, Qn by B, or Qn is equal to B sin theta. So you put all these in equation number 1. So from equation 1 you can write OQ, in place of OQ you can write R square is equal to A square, in place of P you can write A, in place of PQ you can write B square, plus 2 into A, in place of Pn you can write B cos theta. Or here you got R is equal to root over of A square plus B square plus 2AB cos theta. It is your equation number, you take this one as 3 and it is 4. Here is cos theta, so it is called as law of cosines. So here from equation 4 you can find the resultant vector magnitude. So now come to direction. The direction you can get from this angle. Let this angle be beta. So beta and B, you see in beta this line extends up to some extent, but here this line ends at here. So make a distinction between beta and B while writing. So now here question arises, from this angle beta, how can we know the direction of the resultant vector? If you find beta is 0 degree, beta 0 degree means the resultant vector has the same direction as that of A vector. A vector direction is known to you. If you find this beta is 90 degree, means resultant vector acts at 90 degree angle to the direction of A vector. That means in terms of beta, we can know the direction of the resultant vector. So now, in this triangle, OQN, you apply tan beta, that is Pn by Qn, that is P by B, Qn by On, Qn, what is On? OP plus Pn. Qn already we got, that is B sin theta. What is OP? A. What is Pm we got? B cos theta. Or beta is equal to tan inverse B sin theta divided by A plus B cos theta. You know, it is your equation number 5. The data known to you means A vector, B vector and the angle between them. That means magnitude of A vector, that is A, is known to you. Magnitude of B vector, that is B, is known to you. The angle between two vectors means theta is known to you. So in terms of A, B and theta, we got both magnitude of the resultant vector as well as direction of the resultant vector. So now question arises, what is inverse trigonometric function? What is tan inverse? You know x inverse is 1 by x. Tan inverse, that is not 1 by tan. So you remember, if sine theta is x, then sine inverse x is theta. That means if you know sine 30 degree is 1 by 2, means sine inverse 1 by 2 is 30 degree. Similarly, cos inverse 1 is 0 degree. Cos inverse 0 is 90 degree. Tan inverse 1 is 45 degree. So it is your inverse trigonometric function. The concept is same for all trigonometric functions. So now it is the law of cosine. So now come to law of sines. So in this triangle again, OQN triangle, if I write sine beta, what is sine beta? That is Qn by OQ. That is Qn. What is OQ? OQ magnitude length is R, means magnitude of the resultant vector. Means Qn is equal to R sine beta. It is your equation number 6. So here Qn is B sine theta, here R sine beta. From equations 3 and 6, how can we write? B sine theta, you know, R sine beta, or B by sine beta, R by sine theta. Equation number 7. So again, if you draw a perpendicular to this side, let it be M. So you take, it is 90 degree, it is also 90 degree. In triangle OPM sine beta PM by OP. OP means that is A, or PM A sine beta. Similarly, you can take in this triangle PMQ. So you take the angle between it is your R vector. The angle between R vector and B vector is alpha you take. Means that is between the directions. You see it is the resultant vector direction. It is B vector direction. It is your alpha. If it is alpha means it is your alpha. That means you can write sine alpha, that is PM by O, that is PQ. PQ is your B, or PM B sine alpha. It is equation number 9. So you compare 8 and 9. From 8 and 9, here it is PM, it is PM. So from equations 8 and 9, A sine beta is equal to B sine alpha, or you can write, from this you can write A by sine alpha to B by sine beta. It is your equation number 10. So now you compare 7 and 10. In both the equations you have b by sine beta. Therefore, you can write a by sine alpha, b by sine beta is equal to r by sine theta. It is your equation number 11. It is your law of sines. So, you remember, again I will explain it, what is law of sines. If you take here, it is the triangle OPQ. The three sides are represented by A vector, B vector and R vector. So here, I can take, if I will take A, then A by sine, I will take angle between R and B. That is alpha, A by sine alpha. If you take B, then I will take the angle between A and R, that is beta. If you take R, that means I have to take the angle between A and B, that is theta. So it is A by sine alpha is equal to B by sine beta is equal to R by sine theta. It is your law of sines. So, two important formula for magnitude and direction of the resultant vector, that is, you got R is equal to root over of a square plus b square plus 2ab cos theta. And for direction, it is tan inverse b sin theta by a plus b cos theta. So what is theta? Angle between a vector and b vector. If two vectors are parallel vectors, means theta is equal to 0 degree. Then what will be the resultant? R is equal to root over of a square plus b square plus 2ab cos theta, cos 0 degree is 1, that is root over of a square plus b square plus 2ab, a plus b whole square, that is equal to a plus b. It is the magnitude of the resultant vector. Similarly, for direction, beta is equal to tan inverse b sin theta by a plus b cos theta. So if theta is equal to 0 degree, then b sin theta will be 0, sin 0 degree is 0, tan inverse 0 by a plus b cos theta is 1. So tan inverse 0 degree, you will remember tan 0 degree is 0, so tan inverse 0 is 0 degree. 0 degree means resultant vector makes an angle beta with a vector means 0 degree with a vector. That is another direction of a vector, that means another direction of given vectors. Similarly, and you remember here, as maximum value of cos theta is 1, when theta is equal to 0 degree, then R is got a plus b. So it is the maximum value, of the resultant vector. So now come to for anti-parallel vectors. In the same way, if two vectors are anti-parallel, means opposite to each other, means theta is 180 degree, then cos theta will be, you remember, cos 180 degree is minus 1. That is a square plus b square minus 2ab, that is a minus b whole square, it is a minus b. So now you see, you remember, minimum value of the cos theta is minus 1. So resultant vector magnitude is minimum when theta is 180 degree. That means minimum value is a minus b. It is the minimum value of resultant. So similarly, what is the direction? Beta is equal to tan inverse b sin theta by a plus b cos theta. Sin 180 degree is 0 degree. Then it is a plus b cos theta minus 1. So it is a minus b. Again it is 0 degree. Means resultant vector acts at an angle 0 degree in the direction of a vector. Means as a here we have taken greater, so in case of anti-parallel vectors, the resultant vector acts in the direction of greater one. For two perpendicular vectors, perpendicular vectors. Means here theta is equal to 90 degree. Theta 90 degree means it will be cos 90 is 0, you remember. So it is root over of a square plus b square. It is the magnitude of the resultant vector. Similarly, direction beta tan inverse b sin theta. Here theta is 90, sin 90 is 1, so it is b into 1 by a plus b cos 90 is 0. That is tan inverse b by a. So the direction depends upon the angle beta. That depends upon the ratio of magnitude of two vectors b and a. So you remember, it is very important to remember the trigonometric table. So here is a homework to remember all the values of the trigonometric table: sine, cos, tan, cot, etc.